So the project may be kind of overwhelming at first sight. There are many classes. But actually, if you look at those classes, you already know that 5 of them are classes coming from the shape project. Okay, so those are the classes used to draw different kind of shapes on a canvas, and we already use them in a couple of code workshops to build kind of more complicated scenes, right? The house scene and the one with the river and so on. So those actually are the shapes used to kind of create the game. If you try to run the main method to play the game, you will see a maze drawn on screen, and then there is a person that you control using the keyboard, okay? And the way this maze is drawn on screen is actually by using different little squares to kind of draw those lines, all right? So since I was very lazy to write a code to draw a line, I end up just stacking small squares, right? So you can imagine each line to be composed of a bunch of squares in order to format that line, all right? And obviously this is a person object, which is an instance of that person class. So this is an example of object composition. This bigger kind of program is composed of many objects. Some of them have to do with the drawing itself, coming from the figures project, and some of them I wrote to represent the logic of the game, mainly that the person is moving in between rooms in the maze. So actually one of the projects in the textbook is called the Game of Zool. I did not discuss it in class, but it's in the textbook, and there are a bunch of videos, maybe 2 or 3 videos on YouTube about that Game of Zool project. And that maze game actually relies on this idea of the Game of Zool. So let me break this project to 3 components. There are classes which are doing drawing, basically person, triangle, square, circle, and canvas. Those ones you already know about. There are 2 classes that represent the actual maze, which are maze in the room. And this is kind of a conceptual representation of the maze. This is kind of describing how the rooms are interconnected in the maze. The class renderer takes this maze and represents it on screen. Okay? So you've got a kind of a conceptual representation of the maze, and then there is a class that takes this representation and draws it on screen. And finally, there is a class called game, which takes control from the player and moves an object in the maze, and then the maze will get reflected on screen. So you may bump into this kind of design principle called model view controller late in NetApps, or if you're doing work in software design or software engineering. Basically, you want to break a big design to parts that represent the data structure of the problem. This is called the model. And then you want to present this model to the end user. And this is the view part of the project. And then you want the user to take control of the model by interacting with the view. And this is called the control, right? Usually in enterprise application, the model is the data coming from a database or a data warehouse. The view is just, a view of like a tabular format or a figure or a graph. And the controller is interacting with the data, for instance, entering a new, for instance, record or deleting information. In the case of the game, which is more exciting than data modeling or data warehousing, the model is actually a maze. The view is the maze drawn on screen, and the controller is actually the user taking control of that actor on by pressing the arrow keys on the keyboard. Okay. So let's take a look at how the model is represented in the game. At the core of the model, there is a class called room, and room represents different room. The room class actually models a room in the maze. Okay. So each room has a description. It has X and Y coordinates. representing the room location in the map, which row and which column. And each room has actually 4 attributes of room type: north exit, south exit, east exit, and west exit. Now, this is the first time you see this. You see that this is a classroom, and each classroom has 4 attributes called rooms of the data type room. And this is a very common data design pattern. Usually often you want to link objects of the same data type. For instance, let's say you want to represent families in your program. You have a class called person, and this person has an array of persons called kids, for instance. If you want to represent couples, each person has another attribute called person, called spouse of type person, okay? In this case, each room can be linked to different rooms by setting those exits of that room. So let me try to create one instance of this room. Let's say I want to create a room in location 3.3. And if you inspect this room, you can see that there are no exits. Basically, this room is just a cell, like a prison cell, 4 walls, okay? Let's say for the sake of this example, there is a room north to this room, which is, I don't know if I can draw. So I'm trying to draw something on screen. I'm not sure if this would be recorded. So let's say you've got your first room, which is this room at location 3.3, and this is a complete cell, right? Let's say you want to link this room to an adjacent room. So to do this, you create another room at location 4.3, and then you link this room to that room. So now there is an exit in between the first room and the second room, okay? When you do that link, those 2 walls will disappear when this room is drawn. But basically, what you end up doing when you're creating this maze, the model of the maze, you're creating a bunch of rooms, and depending on the structure of your maze, you end up linking those rooms together, all right? So in this maze, this room has 1 exit to the east. This room has 2 exits, 1 north and 1 south. And this room has 2 exits, 1 to the east and 1 to the west and east, okay? The link in between 2 rooms. What I'm really doing, I'm creating 2 rooms. Let's do room, for instance, at location 4 and y is equal to 3. Room 2, and what I do, I link room 1 to room 2. I set the exit of the east. All right, so room 2 should be east of room 1. So what I do, I set the exits to be null, room 2, null, null. So this will set those attributes, and since room 2 is an object of type room, if you inspect, you can see now that this room has a link to another room. So let me change the description of this room. Let me see if there is set description, get description. No, there is no set description, but basically I can add a description to the room. This room has an east exit to the other room. Now the other room, it will have a west exit to the first room. So what I can do here, I will set those everything to null, and this will be room 1. Okay, so this room, if you inspect it, you will see that it has a west exit. So basically now I have 2 rooms linked together in that maze. So the maze itself is composed of a set of rooms, and those rooms are linked together to form the different paths that the person can travel throughout the maze. So can you guess what's the data structure I used to represent the maze? It's a collection of rooms.
You made a room, but you made it out of, like, the circle, or not circle, square?
So forget about how I'm drawing it. Just, just the fact that I have a bunch of rooms. Those rooms are presented in a board. It's like a chessboard, but some of the boundaries, some of the walls in between the cells are broken because I'm linking those rooms together. So each one of those small square is a drawing of a room. For instance, this room has a south exit, an east exit and a west exit. This room has a west and a south. This one has north and west. This one has east and south. Okay? But on this big maze, we have 25 by 25, 625 rooms. And in the maze class, if you take a look, you can see that a maze is actually a 2-dimensional array of rooms. Okay? So what I'm doing in the maze, it's very similar to what you're doing in that in the tic-tac-toe example. I'm creating a new array of size, and size is 25. The one I'm showing to you, it's by 25, but I can change that size. And then I'm going for each individual room and creating a new room. Okay? So basically, when you create a new maze, if I create a new maze, for instance, if I create a new maze of size 3, what I will end up having here is a 3 by 3 array, and each one of those objects is a room. Okay? And each room is linked to different rooms, and this depends on the file that maze object is reading from. So basically, you have a 2-dimensional array of room, and then actually the method that links the room together is this generate maze, which I will skip for now. But suffice to say that for now it's reading from a text file. If you take a look at a text file, maze.txt, the text file is basically specifying the types of the rooms. Each room has a number, and each number determines the type of the room. Okay, so basically that text file is determining the type for each one of the for instance room number. The first room here is of type 4, the second one is of type 14, and the third one is type 12. And each number determines one kind of a room, depending on how many walls it has. So it's as if I coded every room type, because each room has potentially 4 walls. So how many different rooms can you create? Five, okay. So each room has 4 walls, right? North, south, east, west. You can create 2 times 2 times 2 times 2 equal to 16 different rooms. If all the rooms are closed, or if all the walls are closed, this is a cell. For instance, this is one type. If all the walls are open, this is an open space. But you get all the different combinations in between. The north can either be open or closed. The south can be either open and closed. The east and the west too. So you've got 16 different kinds of rooms, and each one has a number, and this file is basically assigning a number to each one of those to each one of the rooms here. Okay. So in the last question in the project, I asked you to generate a random maze, and basically to do it, you will need to think of a way to randomize those numbers. Okay. But for now, those numbers are the same, which means that the maze is the same. If you play that game on your machine, it will be exactly the same maze I'm playing. Okay? So let me create a maze of 25, which is the size of the maze. So if you inspect maze, you can see that this is kind of those are the different rows, 25, and each one of them is 25 columns. And each one of the cells, it's not a number, it's a room. Okay, so room number 0 is basically a room which only has an east exit. Okay, it corresponds to this one. So this room only has an east exit, right? You can only go east. The second room, which is this one, has both east, west, and south. So if you inspect this room, you can see that you can go either south or east or west. And this is how the rooms are linked in that model representing the maze. Okay. Now those are just a bunch of objects. The next step I'm doing is to draw them on screen, right? And this is the job of this class called renderer. So a renderer takes a room and draw it on screen, basically. So this is the core of this class, and you can see that this method takes a room as a parameter, and then it tries to test whether the room has walls. If it has a wall, it draws that wall by lumping together a bunch of little squares. Okay? And it does this for each of the walls. So basically, to draw a room, you're not drawing a room. You're drawing walls if they exist. I mean, there is nothing in the room to draw. Except if there is a person, it kind of draws a little person. Okay? So let me show it to you. Let's try to just create one room. I'm going to create one room, and this room, all of the exits are null, which means they're all walls. I'm going to create a renderer, 25. So the renderer will create the canvas object, and if I invoke the method render room, I need to pass this room as a parameter. Room 1. Okay. Now nothing happens yet. You need to invoke the method refresh. And the method refresh will actually refresh the canvas. So now you've got this room. Okay. Now let's add a little person in that room. If I go to the room and set person in room to be true, so one of the attributes, remember, is person in room. So if you inspect room, you can see that one of the attributes is called person in room, and this is how this, that little person travels in between room. Each room has a Boolean variable, person in room, which will be either true or false. So if I set person in room to be equal to true, it does not appear immediately. You have to render this room again and refresh the canvas. So I'm going to render room 1, and I'm going to refresh, and you've got the little person here. Okay? Let's create another room for the sake of this example. Let's create 2 rooms and make them adjacent. Okay, so I'm going to create another room at location 0, 1. Okay, room 2. I'm going to render room 2. Render room 2. and I'm going to refresh. You've got the second room, okay? Now, if I want to link those rooms together, what do I do? Okay, I need to go to room 1, set its east exit to be room 2, and go to room 2 and set its west exit to be room 1. So what I'm going to do, I'm going to set this one to be room 2, null, null. All right, so the east exit will be room 2, and likely the east exit set exits null, null, room 1. Oh, no, null and room 1. So the west exit of room 2 to be room 1. And next I'm going, actually the renderer has a feature called auto refresh if you want to auto refresh. So you can turn it on. But for now I'm doing it manually. So I will render room 1, and then I will render room 2, and then I will refresh. Okay. So let me inspect. You've got an east exit and the west exit. So I'm going to, I refresh this. Well, let's do it one more time. Render room 1, and render room 2. Okay. So I'm going to set a break. I'm not sure why it's not refreshing that maze. Refresh. So let's do this one more time. If I render room 1, you see that it's testing for the exits. Since there is no north exit, it's going to draw each one of those little squares, which you can't see because it's drawing over existing squares. Yeah, all right. I know what's going on. It's actually the squares. It's not drawing those the exits, the east and the west exit, but they are already linked together because we kind of have created those squares in the previous when we created 2 rooms with walls, so they still show up on screen. Okay, so that's why you can see the wall. It's kind of those pixels are still on screen, so even if it's not drawing them, they still show up. Well, we're not at the go yet at this part. So the job of renderer is actually to take that maze. So there is a method called render room, and there is a method called render maze. And render maze will go over each room and render that room. So basically, what's going on in here is that you will eventually, by creating those little rooms, you will draw the whole maze on screen. Now, this is not yet controlling that person. The control is actually all in the game in a class called game. And basically, there is a big loop, like the loop you have in your tic-tac-toe game. And in this loop, every time you try to read a move, and this move depends on the key press, whether it's up, down, left, and right. Okay, and depending on the move, you try to move that person to the location indicated by the key press. Now this is done using a method called move, and the method move will try to look at the current room and then it examines all the exits of the room. If there is an exit, and for instance, if the player pressed go north up to go north and the room has a north exit, then this is fine. You can move the player to the next room by getting the next room and setting the person. So the person will disappear from the first room and go inside the next room. And then you will need to render that two rooms together. Let me actually demonstrate it in, I'll trace the execution of this game from the beginning. So I'm going to start with a while loop here. All right, so the problem is that it's waiting for a key press, and I did not press any key yet, so let's see what to do here. Okay. Let's try this breakpoint. So whenever I'm trying to press a key, it's actually reading the key and not stopping. All right. So here we managed to break the execution. The person is in this room and I'm trying to go right. Okay, I press the right arrow here. So take a look at this, the four variables, north, south, east, and west. You can see that west is false, east is true, I'm trying to go east, and south is false, okay? Now this move, this will call the move method, and giving the move method information about the directions. So this line will call the move method. If I step into it, you can see that I am now in the move method, and where's this little guy? Okay. In the move method, I have the following information. I want to move east. Right now, I am in the person in room 02, and the person wants to move east. Okay, row 0, column 2, 0, 1, 2. The person is here, and the player wants to move east. So this method will determine if this is a legal move or not. And the way it determines it by looking at the actual room in the maze. So first thing it does, it gets the current room from the maze, which is represented in this variable R. If you inspect R, you can see that this room has two exits, one to the east and one to the west, all right? And this is represented by the fact that this room is linked to the other room. So this is the east exit. You can see that person in room is true for this room, but it's false for this room. So what this method does is basically to make this variable false and this variable true, because the person can move. So mainly it will take the person from this room to that room, because first of all, there is no wall, and second, the player wants to move right, and the person is currently in this room, but not that room. So if you follow down the execution here, it will check for each one of the walls, north, south, east. This is what we want to do. We want to move east. So it's going to check whether the player wants to move east, which is true, and the room has an east exit, which is not null. So what it will end up doing, it will pull the east room stored in that variable R2, and then it will set person in room in the next room, meaning the person now will move to this room. Okay. Sorry, it will set it false in the current room, so it will disappear from this room. The person will be in this room. It has moved. Now at this point, the person has moved in the model, right? If you take a look at your room object, the person has disappeared from the first room and appeared in the next room. You can see that. It has not been reflected yet in the presentation. So after making the change, it will ask renderer to re-render the first room and re-render the second room. So when you render the first room, you will get the person disappearing from that room. Now it hasn't refreshed yet, and this is why you don't see it. And it will render room 2. Now it will set X and Y, because this class, the game class, keeps track of the current X and Y location of the player in those attributes. It will set X and Y accordingly. Okay. Now finally, exit is trying to detect whether the player reached the end of the maze to declare that the game is over. Okay. Now this will ask the renderer to refresh. Once you refresh, you'll see the person moves. Voila. And then return exit to check whether the game is over. Now this is not the exit room, so we will keep running the game. Now sleep 30, this is just determining the speed of the game, because otherwise the person will move very quickly in between the rooms. 30 milliseconds in between, to a move and the other move. And we move. Now we do the next step. If I move, let's try to move east one more time. Hopefully it will pick this press from me. So let's try to move right, east. Again, we do the same thing. We want to move east. Oh, I stepped into it instead of step over it. But you can see that there is a wall here, so the person won't move east actually, because there is a wall. Okay. So I'm going to do it one more time. Where is it? Okay, I'm sorry. So I'm going to try to move east one more time. So I press the right arrow. Now let's see what's going to happen when we call this method move. Now when you call move, you know that the player wants to move east, right? So you're trying to evaluate this branch. The thing is that this room does not have an east exit, okay? So this room, the current room, room R, does not have an east exit. You can see east exit is null. So the moment you try to go east, this condition will be false, and the person will not move, okay? So to move, first, the player has to indicate the intention of moving by pressing the key. And second, the room should have an exit in that direction. Otherwise, you don't move the person. Right?
And then it knows it's over because it doesn't have any, or all the exits are open?
Well, the last room has a special designation. So when you take a look at the room object, let me terminate this program. So when you take a look at the room object, you can see there is an attribute called exit, I think. I'm done. Exit room. So exit room is a Boolean attribute in room, and I'm setting exit room to be equal 2525 in this example. So the moment you hit the exit room, this will test for that condition, and then the game is over, okay? Now, if you, for some reason, make your exit room the second room, then the game would be over before the player, finishes the maze. So this is, I think it's done in maze. When you create your maze, the last room should be the exit room, I think, somewhere here. All right? So, I mean, the first thing you need to do is to understand the design of this project, because each one of those questions is asking you to do a modification. You're not being asked to write something from scratch. But for instance, if you want to break a wall or to add another object to this to this maze, you have to understand where you want to edit. Which part? The model, the presentation, or the control. Okay. So I'm going to give you an example here. Let's say, for instance, you want to give the player the magic power of being able to break all south walls. Okay, even if the south wall does not exist. Then this is the part you want to change. You want to change that get south exit to be able to make this player kind of capable of going south, even if this south does not exist. So let's say, for instance, I want to make the player capable of moving south no matter what. So what I'm going to do, I'm going to edit this part, and I want to get the south exit of the room. So what I want to do when the player wants to go south, I will need to get the room which is south to this room, x, y. So I want to get x. So the room does not have a south exit, but since the player has this magic power, what I'm going to do, I'm going to take x and then y plus 1. It's just jumping one room, even if the wall does not exist. And then I'm going to set the person in room false, true. I think that's it. I'm not sure if it will work, but I have a feeling it will. So let's see now if this magic kind of, think about this as a power up. Now it's given, but it could be conditional on the player. See how I'm jumping in between east walls? So, oh, actually there is an error. I'm jumping east instead of jumping down because I increased y. So, sorry. What I need to do is to, go to main. No, I go to game. I want to increase x by 1. Right, I want to go down because x is counting the rows, not the columns. All right. So this could be a power up. For instance, if the player gets this power up, the player can jump in between those rooms. So now if I go east, I'm stuck, but I can go south and jump over all the south walls because of this magic power up. Okay, I can't go north, but I can go south. Even if there is a wall, I can jump over that wall. All right? Oh, I cheated. All right? Okay, let me try to save.